Hello everyone, this is Professor He. Nice to see you again. The topic of this task is about the second law analysis of vapor power cycle. The ideal Carnot cycle is a totally reversible cycle, and thus it does not involve any irreversibilities. The ideal Rankine cycles, however, are only internally reversible, and they may involve irreversibilities external to the system, such as heat transfer through a faded temperature difference. Relations for exergy and exergy destruction for steady fluid systems are developed in Project 3. The exergy destruction for a steady fluid system can be expressed on a unit mass basis for a 1 unit, 1 exit steady fluid device as where Tb in and Tb out are the temperatures of the system boundary where heat is transferred into and out of the system, respectively. The exergy destruction associated with the cycle depends on the magnitude of the heat transfer with the high and low temperature reservoirs involved and their temperatures. It can be expressed on a unit mass basis as for a cycle that involves heat transfer only with a source and TH and a sink and TL, the exergy destruction becomes the exergy of a fluid system EX at any state can be determined from. Let's recall the energy analysis which had been done before based on the first law. In the steam power cycle, the pump is carried out in an adiabatic process without heat loss. The boiler will cause heat loss due to the exhausted flue gas with higher temperature, incomplete combustion, and heat dissipation of furnace body. The process of steam turbine is adiabatic without heat loss. The heat released by the exhausted steam in the condenser is discharged into the atmosphere through the cooling water, resulting in heat loss. The total energy balance of the system is low heat value of fuel equals total heat losses of pumps, boilers, turbines, condensers, plus work done by the steam turbine minus work consumed by the pump. The thermal efficiency is work done by the turbine minus work consumed by the pump over low heating value of the fuel. Now, let's provide the exergy analysis based on the second law for a real Rankine cycle. The actual vapor power cycle differs from the ideal Rankine cycle as a result of irreversibilities in various components. Fluid friction and heat loss to the surroundings are the two common sources of irreversibilities. Of particular importance are the irreversibilities occurring within the pump and the turbine, as shown in Figure 11.20. A pump requires a greater work input, and a turbine produces a smaller work output as a result of irreversibilities. Under ideal conditions, the flow through these devices is isentropic. For 1 kilogram of fuel, exerted destruction in pump is exerted destruction in boiler is exerted destruction in turbines is exerted destruction in condensers is total exerted destruction then is. Here now, the second law efficiency or the exerted efficiency of this power plant can finally be determined. For the details you can find in the textbook. The second law efficiency is the ratio of the recovered exergy and the expended exergy. The expended exergy is the exergy content of the heat supplied to steam in boiler and the pump input. The exergy recovered is the work output of the turbine or the difference of expended exergy and total exergy destruction for the system. Okay, that's all for this task. Thank you very much and see you next time.